So imagine you're looking at like this massive spreadsheet of daily rainfall totals for the past year.
Okay, yeah. Sounds like a lot of data.
Right. And someone asks you for the total rain between, say, day 5 and day 20. I mean, you could just drag your cursor and add those 15 days up.
Sure, you could.
But if they keep asking for different date ranges all day, you're going to be recalculating constantly. It's just not efficient. So today, welcome to the deep dive. We're taking a stack of coding interview research and LeetCode solutions to help you tackle this specific, really powerful pattern, the prefix sum.
Yeah, the underlying philosophy here is trading a one-time O of n setup cost, for instance, O of 1 query speeds.
Wow. O of 1, that is the dream.
It really is. So instead of adding up that rainfall from scratch every single time,
Yeah.
you just create a running total array.
Right. So to get the rain from day 5 to 20, you just take your pre-calculated total up to day 20 and subtract the total up to day 4?
Exactly. You do the heavy lifting once, and then every subsequent question just takes a single subtraction.
That's brilliant.
It is. The core formula we see across all the sources is basically prefix r plus 1 minus prefix l.
Okay, where R is the right boundary of your range and L is the left.
Spot on. But there's a really common mechanical error here. Like, to avoid stepping out of bounds when you query the very beginning of the array, the standard practice is actually making your prefix array length n plus 1.
Oh, so you put a sentinel 0 at the start.
Yeah, exactly. You just drop a 0 at index 0. It handles those tricky left boundary conditions natively, so your code doesn't crash.
Well, a running sum makes perfect sense for basic range queries, but I mean, the harder LeetCode problems don't just ask for a simple sum.
No, definitely not.
Right, like number 525, contiguous array, they actually ask you to find a subarray that meets a specific condition.
Yeah, in 525, you have an array of just zeros and ones.
And you need the longest continuous section with an equal number of both, right?
Exactly. And that problem really highlights the true power of this pattern. The research points to a very specific, almost magic transformation trick.
I love magic tricks. What is it?
You iterate through the array and change every single 0 into a negative one.
Wait, really? Just flip the zeros to negative ones.
Yeah. Because think about it. If you have equal zeros and ones...
Oh, I see. If we do that, we aren't looking for equal counts anymore. The positive ones and negative ones will just cancel each other out.
You got it. So we're just looking for any subarray where the total sum equals 0.
Which brings us right back to the prefix sum.
Right back to it.
Oh.
But doing this in O of n time means we can't use nested loops to check every possible subarray.
No, that would be way too slow.
Way too slow. So we have to pair the prefix sum with a hash map to track the frequencies of the running sums as we go.
Okay, but wait, let's think about how that actually works under the hood. If we're tracking frequencies of sums in a hash map, we have to consider the formula. Because it calculates a range by subtracting the prefix sum just before the starting index. So what happens if our valid subarray starts right at the beginning, like at index 0?
That is a great question and a huge trap.
Because the prefix sum before index 0 is technically empty, which means its value is 0. So if the hash map doesn't already know that we've seen a sum of 0 before we even start iterating, the math just breaks.
It completely breaks.
We'd totally miss any valid subarrays that start at the very first element. So we have to manually initialize the map, right? Like with a key of 0 and a value of 1.
Yeah, like curly brace 0:1. That logic is exactly why this step is so crucial.
It's like a silent bug otherwise.
It is a notorious silent bug. The code compiles, it runs perfectly fine, but it drops valid arrays starting at index 0, which will absolutely fail the interview test cases.
Man, that's brutal. So beyond remembering to seed the hash map, what's the broader strategy for you when taking this into an actual interview?
I'd say always verbalize the transformation. Say out loud, I'll pre-compute a prefix sum array, so these range queries become O of 1 subtractions.
Right. It shows, the underlying mechanics, not just a memorized solution.
Exactly. And you also need to demonstrate, its limitations, like prefix sums only work efficiently for static arrays.
Oh, because if the data updates, say those daily rainfall totals are getting retroactively changed, you'd have to rebuild the whole thing.
The entire prefix array on every single update, yeah. In that scenario, you'd need a dynamic structure, something like a segment tree.
Right. Use the right tool for the job. Well, as we wrap up this deep dive, let's step away from the code for a second.
Okay, let's do it.
I want to leave you with this. Think about that underlying philosophy of the prefix sum. Paying a small one-time setup cost upfront to make all future queries effortless.
It's a really great concept.
It really is. So how can you apply that concept to optimize the bottlenecks in your own everyday life and workflow? What's your personal prefix sum that could, save you from constantly recalculating your daily tasks? Think about it.